Hello everyone, welcome to another video of Data Engineering Zoomcamp Week 5, and in this video I will talk about RDDs in Spark. RDDs stand for Resilient Distributed Datasets, and this is something that's very internal to Spark that the very first versions of Spark had. So this is the basis of what it uses for doing distributed computations. And data frames that we saw are built on top of RDDs. So this is another layer of abstraction that gives us this nice API and nice functions so that we don't actually need to use RDD. And most of the time we do not indeed need to use them. That's why I mark this section as optional. So both this video and the next video will be optional. And this is more like a bit of history for you to see how things were done before, like 5 years ago. And I will show you how some things are implemented internally. So you might decide to actually stay and watch it. So it's actually 2 videos. I keep changing the plan. For RDDs, there is an entire section of 2 videos. So in the first section, we will talk about simple operations like map and reduce, and we will talk what RDD is. In section 2, we will talk about one specific operation, that is map partition, which I find quite useful. It's actually not correct. I find it quite useful, and I still, even though we have data frames, I still use it quite often. So let's start with RDDs. RDD is a distributed data set. So let's say we have some data set that is partitioned. So we have a bunch of partitions, I don't know, partition 1, partition 2, etc., partition 50. This is distributed. So if let's say we have a bunch of executors, then each executor takes each partition and executes it. And so we saw this already in dataframe, and actually data frames are implemented on top of RDDs. So internally there are still RDDs, but they follow a specific structure. They have a schema. I will write it here. Data frames, they have schema and usual RDDs. This is just a distributed collection of objects. And this is a distributed collection. Maybe it's better if I just show you. And what I will do is I will create a new notebook. I will call it 08 RDDs. Let me open one of the previous projects. So I will use this Spark SQL. So let me copy this thing and execute this. So now our local master will start. We can actually check that. Localhost 4040. Yeah, we have it. And I will read green dataset here. So what I want to do in this video, let me open another one. In the group by example, in the group by video, we implemented this query. So in this query, we computed revenue per hour per each zone. So we looked at the total amount of trips that originated from this pickup location at a specific hour. So I want to take this query. I will copy it right now here. And this is something I want now to implement, but with RDDs. Before we go into doing that, so we have a data frame, right? If I do show, we will see this data frame. And in a data frame, there is a field called RDD. And this is the internal, the underlying RDD of this data frame green. And I can use this take 10, and we actually saw this already. If I just do, collapse it, if I just do data frame green take, I go with 5. So it also returns a list of rows. The data frame that we have is built on top of RDD of rows. So row is a special object that is used for building data frames. And when we do this green take 5, we get 5 first rows. And we can do anything with these RDDs. There are some basic operations that I will show you. But first I want to keep only, you see, we have quite a bunch of columns in this row. So I want to keep only those columns that are needed for us, which are, I'll just do select, and then we'll do RDD next. So in select, I will select only columns that we need. The first one is this one, this LP pickup time, then zone, then total amount. We do not need this count because it just simply counts the number of records. So for reproducing this query, we just need these 3 fields. And then this gives us an RDD, which if we check now, take 5, yeah, it has only the fields we need. First thing we can do, we can implement this thing, the where clause. So here we are interested only in records that are either 2020 or later, because we have some outliers that are coming from some earlier days. And for that, we can use this RDD, and there is a function called filter, which filters every record that we have here. In this filter, we can just have any function. So for example, I can have a function lambda row, and then it returns true. It means that it will keep all the records. So if I do now take 1, yeah, it will return. And now if I do take row false, now it will apply to the entire data set, and it will filter out everything, and then at the end there will be nothing to, yeah, it returns an empty list because there is nothing there. We filter out everything. So we can use this for doing this thing. So for that we will need to use datetime object in Python, because this is what internally is used. Datetime, from datetime import datetime, and we'll create the start, which will be year 2020, month 01, just 1, and day 1. And we'll have this row. So in the row we have this lpep pickup datetime, which is greater or equals to start. We can take another example, maybe something from 2021, just to see that it works. So you will actually need to do some filtering. I hope I have some data from 2021. I do. This is how it works. So this is how we implement the where part. Actually, it's a good idea. Instead of using lambda, maybe we can put this in a Python function. I'll call this function filter outliers to have row, and then I will return this thing, and I will put it here. So it's still the same thing, just I'm putting this in a separate named function, which is a lot better than lambda, because lambdas can get messy quite fast. So they implemented this part, and now let us implement this part. And also at the same time, we will start thinking about group by. I want to go back to the slide where we discussed how group by works. Here we talked about that we apply this thing to each partition, and as the result of this we have a sub-result of each partition that looks like this. So we have our zone 1, which is the key, and 105, which is an intermediate result. So this thing is the key that we use for grouping by, and these are the values. So we now need to do something similar to have a lot of intermediate results, which we will then reduce to something like this. Except now, for each row of the original data frame, we will produce such an intermediate record. And then on the second step, we will reduce this into 1. But let me show you, because it might be confusing if I just say it like that. Now we need to apply the map function. So what filter is doing, it's a function that returns either true or false, and the purpose of this filtering is discarding some records. So map is applied to every element of this RDD, and we get something else as a result. We have this map function. It gets in some object, in our case row, and then as the output there is something else. It applies some transformation to every element of our RDD, and here we have some RDD, and as a result we have some other RDD. To be able to do group by, the output that we will have need to look like that. So it will need to look like key and value. In our case, key will be a composite key, which consists of hour and zone, and value will be also a composite value, which is amount and count. This is the result we want. This is why here we need to output something that for our particular case, key will be hour and zone, and value will be amount and 1. So for each record we will have 1, and then we will sum all these ones later when we will do grouping. So let me implement this. I will create another function which I'll call transform. Yeah, this is a boring name, but I don't have a better name. I want to see the names. So if I do RDD take 10, and I'll put this in rows, and if I do a row 0, sorry, rows 0, it will be a row. I have this row, And now I can experiment with this row without going inside the function. So to access some elements of the row, I just do row dot, the value. So this is the pickup time. And I need to truncate it. This is what we did here is we truncated it to hour. And I think for, this is replace. And we need to replace minute with 0, then second with 0, and then millisecond with 0. It's actually not millisecond, but microsecond. Okay. I don't think we have anything on microsecond resolution in the original date time, but just in case I will reset it as well. So this is what we have right now. So this will be our hour that we have here, our hour, and now we need zone. So zone is, let me print row again. So zone is this PU location ID. Of course, row dot. So this is our key, and now we need our value. The value is, we have amount, which is row total amount, and then count, which will be just 1. And now we need to return. We need to return a tuple because later we want to aggregate this tuple. So we need to prepare it in this format. It will be a tuple with 2 values, key and value. And the key for us will be a composite key with hour and zone. And then the value is also a composite value with amount and count. So we will have a tuple. The first element of the tuple is also a tuple, and the second element of the tuple is a tuple. This is a bit complicated, but this is what we need to do in order to do group by later. So now we add this transform. Maybe I'll call it prepare for grouping. I'll just do take again, just to see how the results look like. And this is how they look like. So we have this tuple. The first element of the tuple is the key, which is tuple with the hour, and then the zone. And then here we have amount, and 1 is just for counting. And now we need to take this thing, these values, and combine them into 1. And for that we use a thing called reduce. So it takes 2 things, 2 values. It's actually called reduce by key. Here, reduce by key. So let me draw it. It gets an RDD that is in this form, key value. So this is the input RDD, and the output is key and then reduced value. In input RDD, we will have a lot of elements of this RDD with the same key, but after reduction, after using this reduce, there will be only 1 element with this key. So it will take a group of elements with the same key. Let's say this is key 1, key 1, key 1, something. And then let's say there is key 2, and again key 2. The result will be only 1 record with key 1 and only 1 record with key 2. So it will reduce all these values into 1. And the same will happen with this key 2. And the way it works, this reduce function, I'll just call it for now reduce, it actually gets 2 values. So it gets, I'll call it left and right. So the way it works, let's say we have key 1 and then value 1, and then we have again the same key 1, value 2, and then key 1, value 3. So what happens is we first invoke reduce on this pair. So reduce will get value 1 and value 2, and then we'll create something new. It will be, let's say, value 1 plus value 2. This will be the result. Then it will take output of the reduction of this pair and will again invoke reduce to the third value. This is very abstract, but let me show you now how it actually looks here when we talk about our example. So now in our example, remember, we want to count these 2 things. So we want to count the total amount and we want to count the number of records. And here, so this is left value and right value. So these are the things that are coming from here. And remember, we have this composite value. I will unpack now this left value. So I will call it left amount and left count. And I'll do the same thing for the right value. Right amount and right count. And what I need to do is I need to produce a value that looks exactly like this, that follows the same pattern. So output value again should be a tuple with 2 records. So it should be output amount and output count. And in our case, output amount will be left amount plus right amount, and output count will be left count plus right count. So effectively what we are doing here is we first are doing this sum, and then we get something like, I don't know, v2 star, and then when we invoke it second time, we do v2 star and v3, which is this v2 star plus v3, which is some other value, let's say v3 star. Right, and this way we take everything that belongs to one key and we reduce them to one value. So now we need to return this. Instead of returning output value, I will return this tuple. So this way we reduce these records that we created with map. So I'll put it here, reduce, I don't know, I'll call it something like calculate revenue. And then I'll put it here. And then let me execute this thing one more time. It's taking a bit of time. Maybe I should have used a smaller data set. Yeah, it's now performing this group by. And we see that the result, it follows the same format as previously. So first we have this composite key, and then we have composite value, except that this time it's actually an aggregated version. This is a sum of all amounts, and this is the sum of all counts, so the sum of all ones, which means that this is the total number of records that we had in this hour for this zone. This is not, this nested structure is not really nice. Now we want to turn it back to a data frame, and we want to unnest this. To unnest with this, we can do another map. So we will apply a function to each element of this RDD and unnest it. So I will call this function unnest or unwrap. Let's go with unwrap. So we have this row, and then the result will be row 0, 0, this one. So first we access the first tuple, and then inside the first tuple we access this value, and then we'll have another one. Now we are unpacking the first element of the value, and now we're getting the second element of the value. Now we will have one tuple that contains all the elements. So let me do map one more time with this unwrap, and the result we will get should look nicer. So it will be tuple with just 4 elements. And now we want to turn it back to a data frame. For that, we just use this 2df. Then I'll just do show like we do previously with data frames. Again, it will trigger the whole thing now. And it will show us a data frame, except this data frame will probably have no column names because column names are lost here. Also, the schema is lost. It will try to figure out the schema. Now we can see that the names are gone. And what we can do to make it easier for it is we can use a named tuple. So it's from collections import named tuple, and then we will have a class that we'll call revenue row. Something like this. It will be a named tuple. The name will be revenue row, and then I think it needs we need to give it a list of names of this named tuple. So the first one is hour. Right, then we have zone, then revenue, and then count. And here in unwrap we will do, so hour will be this one, zone this one, and revenue this one, and count this one. So let's execute it one more time. It finished, and we see that it correctly figured out the names. And maybe I'll call it data frame result, and instead of doing show, I will just do that. Yeah, it's actually running something right now, and the reason it's doing this because it needs to figure out the schema. We didn't specify the schema, so now it actually tries to go through all these records and see what should be the schema, because we don't provide the schema upfront. But we can see now schema. And we can tweak it. We can tweak it again like we did previously. I'll add types here and everywhere. These are strings. This should be capital. Zone, I don't think it's long, it should be integer. And the rest revenue is double, and count is long, yeah, it's fine. Well, here I think integer is also fine because we don't have that many trips in 1 hour. But let's say if within some hours we can potentially have more than 2 billion rows, then we'll need to go with long. And this is the schema. I'll need to import this. So let me do this from PySpark SQL import types. And now I'll call it result schema. And here I just provide schema, and then you see it doesn't execute anything, so it doesn't try to infer what schema is because we're providing the schema here. Yeah, this is the schema we provide, and if I now do show, then it triggers the execution. Yeah, we see that this is the result. Now let me save it. I'll do write parquet, something like TMP green revenue, something like this. And the reason I want to save it, I want to look at the execution graph. So the execution graph we have is, let's take a look. So we have 2 stages. Yeah, so they look a little bit, they have more things than what we saw in SQL. But probably, yeah, because here we use this map partition, so it kind of incorporates that. Yeah, but it's also 2 stages like before, like in the SQL example. And the reason we have 2 stages here is because we have this reduce by key. Like here is doing reshuffling. And the reason we need to do reshuffling is we have a bunch of partitions. So we have partition 1. Let me write it here. A bunch of partitions. And then for each partition, we apply a map function, which turns our record into this our zone thing and then value. And we do this for every record. And now this is key 1 and this is key 2, and then we have here key 1, key 2 as well, and here we have key 1, key 2, key 3, and we need to make sure that all the keys, key 1 from here, from here, from here, they end up in the same partition. For that we are doing reshuffling. So they end up in this key 1 partition, and then the key 2 thing, they go here. And then key 3 ends in a separate partition. So we still need to do this. We still need to be in the same partition. And that's why we have 2 stages. This is the first stage. And this is second stage. Okay, so this is all I wanted to show you. So I wanted to show you how to express this SQL statement in RDD terms. And we did this. So this is how we did this. First, this was the where statement, where we filtered out outliers. Then we needed to prepare for mapping. So this is that part, the select part. So we had a tuple, so this is the key by which we group, and these are the values that we want to aggregate. Right? And then the next step was the actual aggregation, where we would do the sum and count. And because we needed to format some specific format internal to Spark, we needed to unwrap it, and then we turn it back to a data frame. So this is how we can do group by if we ever need. Usually we do not, and this was more like to illustrate how things were done many years ago. Now, because we have data frames, we have SQL, we don't need to write code like that. But maybe for somebody is still interested in how to use these low-level operations, and yeah, sometimes it can be useful. And actually, in the next video, I want to show you how to use one quite useful operation, map partition, on RDDs. And this is something we will talk about in the next lecture. So see you soon.